Look at this problem. This one looks more exciting than the other ones, right? So we're going to add some complexity with this one. Now we've got two masses and we've got two input forces. All right, so U1 and U2, those are going to be our input forces. Now we also have these three springs also. We want to get our state space representation. The outputs are going to be the displacements of the two masses. So notice we have Y1 and then Y2. First thing you need to do, get the equations of motion. Now I'm not going to go through all the free body diagrams and everything. I'm just going to give you the equations because I am confident y'all can find the equations of motion. So we're going to have M1, Y1 double dot. That's going to equal negative K1 plus K2 times Y1 plus K2 Y2 plus U1. Alright, so that's the equation of motion for M1. And then the one for M2 is M2 Y2 double dot equals K2 Y1 minus K2 plus K3 times Y2 plus U2. So those are your two equations of motion. So again, do it the long way by drawing out the free body diagrams, or you could use the impedance method and then do the inverse Laplace of all the terms to get the differential terms. Now what we want to do is create our variables, so our state variables. Now remember I said we had to have a position and velocity for each mass. That means in this problem we're going to have 4 variables. Alright, so I'm going to call them x1. That's going to be y1, so displacement of m1. x2 is going to be y1 dot. That's the velocity of that mass. x3 is going to be y2, so displacement of m2. x4 will be y2 dot, so velocity of m2. Now that we got this done, we're going to take the derivative. So take that derivative, and then that's going to give you x1 dot equals y1 dot. Now what does y1 dot equal? Look right here, x2. Now x2 dot, that has to equal y1 double dot. Well, now what are we going to do with that? That leads us to this equation of motion. So we need to solve this for y1 dot, or y1 double dot. That means we need to divide through by m1. And then let's write out our equation. So we're going to have the negative k1 plus k2 over m1. This is multiplied by y1. So we want to replace that with our state variable. So x1. And then next we are going to have k2 over m1. Now we have y2. Well, I don't want to use y2 in this equation. I want everything in terms of my state variables. So y2 is x3. And then finally we're going to have 1 over m1 times u1. Like that. Alright, and then we keep going. So x3 dot is going to be y2 dot. And what's y2 dot? Well, that's x4. That one was easy. And then finally this last one. So x4 dot is going to be y2 double dot. That one leads you back to this second equation of motion. So now solve this for y2 double dot. You just need to divide through by the m2, and then we're going to replace the y's with our state variables. That's going to give us k2 over m2, and then y1 gets replaced with x1. Then we have this minus term here, so minus k2 plus k3, put that over m2. It's multiplied by y2, so I want to replace that with x3. And then finally we have this u2 term. So that's going to be plus 1 over m2 times u2. Now we're done with the hard part. Okay, so now let's put it in matrix form. So we're going to have x dot over here on the left. So that's just basically this column right here. So just write those out. And then that's going to equal a matrix A times matrix X. Matrix X is this column right here. It's your state vector. And then we're going to have a matrix B times our inputs. Now here we've got two inputs, right? We have this U1 and then we have U2. That means we're going to create a column vector. So we'll have U1 and U2. All right. So now we just need to fill everything in. Not too bad, right? So for this first one, x1 dot is equal to x2. So when I multiply these matrices out, add them up, I should just get x2. That means this needs to be 0 because I don't have x1. This needs to be 1 because that's multiplied by x2. The next two will be zeros because I don't have x3 or x4 in my equation. And this over here in the B matrix, this top row, will be 2 zeros because I don't have U1 or U2 in my equation. Now we go down here. So just pull off these coefficients. So we got the negative K1 plus K2 over M1. X2 is missing, so this goes to 0. X3 is K2 over M1. And then x4 is not there, so that goes to 0. Now this one we do have U1. We have 1 over M1 U1. Now U1 is up top here, so that means we're going to have 1 over M1 and then 0. Couple more rows. Third row for x3 dot, that needs to equal x4. So your coefficients for x1 through x3 will be 0, like that. And then you'll have a 1 for the x4 coefficient. No input force here, so both zeros. And then finally we get down to this last row. So here we got K2 over M2. That's the first element in that row. X2, not there, so that's 0. This is x3. So just write that coefficient in the matrix. X4 is not there, so put 0. And then finally, U2. We have that here. So that's 1 over M2. Now we do not have U1, so this one goes to 0 because this element multiplies by U1. And then this will be 1 over M2. Now we have to do our output equation. So you have to figure out what you're trying to get out. We're told we want displacements, but what represents displacements? That's the question you need to figure out. Whoops, missed a word. So let's put what represents displacements. What variables? So if we look over here, our displacement variables are y1 and then y2. Now come down here and figure out the variables. We said x1 was equal to y1, so well, that's one of them that we need. And then y2 is our other variable. Well, we said x3 was y2, so that's going to be the other one that we want. Okay, so when we multiply c times x, we want to get these out. So let's go ahead and write this out. Now this one we're going to get 2 out, so I'm going to have a y1 and a y2, and that's going to equal our C matrix times x. So this top row, let's just say that we get x1 from this one. So that's going to be 1, 0, 0, and 0. Because remember, again, you're going to have 1 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4. All right, so you get that x1 back. That's what we wanted. y2, that's going to be the x3. So let's put 0, 0, 1, and 0. When you multiply this bottom row by this, you end up with x3. Okay, so that's how you get C. Now I do want to point out, I was going to say show, I want to show you guys what students do a lot of the times, which is totally wrong. So let's put don't do this above this. And let's put X here. Now what students do a lot of the times when they want two things out, for instance, is they'll just create one matrix. They'll just do that. Not one matrix, but one row. Okay. So they say, well, this is 1 times x1 and this is 1 times x3, so that's good. Well, if you think about the linear algebra there, that is not correct, because what is this really going to give you? That's really going to give you x1 plus x3, which this is not what we want. So you don't want to do that. So this is like totally wrong, so don't do that. Okay? Unless you're asked to find the sum of the displacements for some reason. So just remember separate row for each one. Okay? Alright guys, hopefully you like that one. Y'all have a great day.